Welcome everyone, and today we are going to deeply discuss what is an active suspension found in vehicles. Well, this active suspension has been developed more recently, and in recent years we've seen it in more sophisticated vehicles such as Porsche, Rolls-Royce, and many others. We're going to start with the introductions, benefits of the system, what the system is made up, and then we're going to talk about the actual operation. Introduction: it was developed in the Grand Prix world. This is Formula One. Conventional systems are always compromised between soft spring for comfort and harder spring for better cornerability. A suspension has to fulfill the following: number 1, absorb bumps; number 2, control body movement; number 3, manage nose drive when braking; number 4, prevent roll when cornering. This means other function has to be compromised in order to fulfill others to a greater extent. Operation: it allows the best without compromising. Achieved by replacing the conventional spring with double acting hydraulic unit controlled by the electronic control unit, which receives signal from sensors. Oil pressure of excessive of 150 bars is applied to the hydraulic unit from a pump. A servo valve controls the oil. Benefits of active suspension: improved riding, handling, comfort, and the safety. Predictable control of the vehicle under different road conditions. Sensors, actuators, and systems operation. A number of sensors are used to provide information to the electronic control unit. Number 1, load sensor. A load cell used to determine where the actual load is positioned on each hydraulic ram. Displacement and vertical acceleration. It takes various forms of a simple variable resistance, such as a linear variable displacement transducer. Well, you might look from my previous videos that I've done. I've explained well what is an LVDT, linear variable displacement transducer. Lateral and longitudinal acceleration. Acceleration can be determined from a pendulum type sensor using strain gauge linked to masses on devices similar to engine knock sensor. Yaw transducer. Yaw transducer can be determined from lateral acceleration if sensor is mounted at the front or rear of the car. Steering position. Rate of change is determined from rotary position sensor. This device can be a light beam and a detector type. If the rate of change of steering is switched to harder suspension setting. Vehicle speed. Speed of the vehicle taken from the standard type sensor used in operating a speedometer. This can be any sensor, ultrasonic, bimetallic strip, or other things. So throttle position, which I've not discussed, but you can do your homework very well and Google from the internet and find how the throttle position helps in achieving active suspension. Driver mode and selection. A switch which is provided allowing driver to choose soft or hard setting. A layout of the suspension system with hydraulic unit. This in effect a hydraulic ram and can have oil under very high pressure fed to the upper or lower system, or upper or lower chamber. Actual operation. As wheel meets a bump in a road, there is increased upward acceleration and vertical load. This is then fed to the electronic control module, which then calculates the ideal displacement. A control signal is sent to the servo valve, which control position of the hydraulic unit. By considering information from various sensors such as lateral acceleration sensors, which give data relating to cornerability, a longitudinal sensor giving data relating to braking or acceleration, the actuators can be moved to provide maximum stability all the time. I hope that one has helped you. Feel free to subscribe to my channel for more informative videos. You will not miss this in your exams, and I hope you'll get the maximum marks if you're asked in your exams.